New chapter. We're going to be looking at chapter 5, and pretty much chapter 5 is all about trigonometric identities, and we're going to be using them for a lot of things. So, but before we get into all of that, let's just go back and make sure we know of some things. We actually are familiar with some trig identities, and then we actually have some new ones from our work in chapter 4. So we'll begin there, and then I'll slowly build into all the things we're going to be doing and examples of how to do those items. So to begin with, let's make sure we truly understand what an identity is. Essentially, what an identity is a situation where we have an expression or a function, if you would, that's the same for everything in the domain. So equivalent, how about I say equivalent expressions or functions, all right, for all x in a domain. And you guys have actually used this before. Think back in the day when we had a polynomial like 3x squared minus x minus 2. All right, what you guys learned how to do is you learned how to factor that. Some of you factored it with the AC method. Some of you factored it with the guess and check method. But no matter what you did, we found that this trinomial here basically breaks up into this product over there. And this is true for all x in the domain. The reason I know that is because I can go to my graphing calculator, all right, and I can graph that parabola 3x squared, oops, let me do that right, 3x squared minus x minus 2. When I go graph that parabola, right, there's the parabola that we get. So it looks like it has, let me get that glare out of there. Right, so it looks like it has some intercepts roughly at about -1 and 2, and maybe a y-intercept at about -2. But when I go graph the other function that is in factored form, parentheses 3x plus 2, parentheses x minus 1, when I go graph that one, its graph is basically the same graph. That's why we're not getting any new graph. You can see the calculator working there. So we basically have the same graph. So we can basically say that this side and this side are identical to each other. And the payoff there was back in the day when we were finding equations. All right, when we were solving 3x squared minus x minus 2 equals 0, what we did is we used its identity or its equivalent factored form. And then that led to the zero factor property, which means that one of these things is equal to 0. And then we can find their solutions, right? Subtract 2 and divide by 3, and we end up getting -2/3. And there was a whole lot of stuff with that. We either had a solution on a graph. We now had intercepts, which we can pretty much see on that graph, right? There's an intercept at 1, 0, and the other one's at -2/3, 0. So we were able to answer a lot of questions based off of that by just using an identity. And so we're going to take advantage of the fact that something is true for all x in the domain, meaning that the graphs are the same, or that the expressions are identical for all x. And that is what a trigonometric identity does as well. It's going to, one of the payoffs, as you will see later in the semester, is it helps us solve equations and so many other things. So now that we know what identity is, let's review what identities do we know. And you guys have gotten pretty proficient at these ones. I think you've gotten so proficient that they're almost automatic. Our reciprocal identities. We know that the cosecant of x is 1 over sine of x, right? And of course there's the flip of that. Sine of x is 1 over cosecant of x. So there's one set of reciprocal identities that we're aware of. And we took advantage of that in graphing and in all kinds of situations thus far. We also know that the secant of x is 1 over cosine of x. And we know that cosine of x is 1 over sine of x. Excuse me, secant of x. Sorry about that. All right, so that was another set of reciprocal identities. And then, of course, we had cotangent of x is 1 over the tangent of x, or we can say that tangent of x was 1 over cotangent of x. Okay, so those are our reciprocal identities. Watching you guys work over the last few weeks, you have gotten very good at that. You've been using it like crazy. Another set of identities that we've had are the quotient identities. Okay, this said that the tangent of x is sine x over cosine x, or the cotangent of x, being the reciprocal, is cosine over sine x. So we had our two quotient identities that we've used quite frequently from time to time, right, to do some work. And then we have also had the Pythagorean identities. Oops, make sure I spelled that right. Okay, the Pythagorean identities. And that was the most famous one of them all is cosine squared x plus sine squared x is equal to 1. Right? The other two are the tangent squared of x plus 1 is equal to secant squared x, and then 1 plus cotangent squared x was equal to cosecant squared x. So those are the big ones we've used. I think we've had an opportunity to use a lot of the reciprocal and the quotient, and we have used the Pythagorean identity from time to time, and we're really going to need them big time. Let me put these in red, because if you go back in time, another type of identity we had was the cofunction identity, but we called them identities at the time, but this set we're actually not going to include here because they're actually not true for all x in the domain. These were only true if we had complementary angles. That's when these were true. If you remember, we know that the sine of theta was the cosine of 90 minus theta, right? Or in using the new language, pi over 2 minus theta. So we're going to find that these cofunction identities, I think there was sine and cosine, cotangent and tangent, and secant and cosecant. We called them identities way back when, I think in chapter 2, but we're not going to really use them here in these identities for two reasons. One, we're going to learn a new way to talk about the difference of a sum, and two, it's not really true for all x in the domain. Remember, we were only talking about angles that are complements to each other. If we're not complementary, those cofunction identities broke down. So keep in mind, in the whole scope of things, in terms of identities that we've learned, these are the big ones: the reciprocal, the quotient, and the Pythagorean. And even though we called the cofunction identities cofunctional, right, they are not really going to be identities. All right, and it turns out that those are the old ones that we knew about, and it turns out that there's some new ones based off of the graphing that we did. What we have are what are called even or odd function identities. Let's do the even ones first. Recall back in graphing, what we found is that the cosine of function was what we call even, meaning that its graph, when we graphed cosine, and there's just a really rough sketch of it, its graph was symmetric about the y-axis, and this is a classic case of an even function. So that means that the cosine of a negative value is equal to the cosine of a positive value, and since they're reciprocals, this also means that the secant of negative x was going to be even. So this is a new set based off of the graphical information that we had done with regard to cosine and secant. And I'll refer to the cosine graph because we know secant is basically the reciprocal. So if cosine's even, that means secant's even. And then what about odd? Well, the other four were odd. And let me write down what those things are, and then we'll look at the graph. So the sine of negative x is the negative of sine x. The cosecant of negative x is negative cosecant of x. The tangent of negative x is negative tangent of x. And the cotangent of negative x is equal to negative cotangent of x. And so these are called the odd ones. And the reason being, again, if we look at the graph of sine, sine did something like this. And if we double flipped it, right, or rotated around the origin, right, this was symmetric about the origin. And this was symmetric about the y-axis, by the way. And the same thing with, so it makes it an odd function. Same thing with tangent, right? Tangent graph looked like this with the asymptotes. If we double flipped it or just rotated around the origin, this graph becomes that graph. So again, it's an odd function. So we're just basically using what it meant to be an odd function. I think even functions, f of negative x was equal to the function. And so we're just saying it cosine and secant-wise, trigonometric-wise. For an odd function, f of negative x equaled negative f of x. And we're basically just saying that for the sines and cosines, tangents and cotangents. So there's your set of trigonometric identities. We have reciprocals, quotient, and Pythagoreans. Those are the ones that we're used to working with from the past. And then the new ones are the even and the odds that we're going to have to add to our list. I strongly encourage you guys to memorize these. I think you guys have gotten these down, but these are probably relatively new because this is going to be very helpful in a lot of situations if you can just identify them and use them, as you will see coming up. All right, so how about we shut this one down and we'll start using some more videos talking about how we're going to be using all these identities.